Okay, so now in this video we're going to illustrate the remainder estimate for the integral test using rectangles to represent the area of the series, just like we did in previous videos. So in this case here, so this represents the case where we have the rectangles underneath, right? So we have these intervals, capital N. So basically we're starting at rectangles at some positive integer, capital N, and so we're going this way. And so notice that all the rectangles are underneath the curve f of x. And so we know that for this one here, that the remainder is all of the terms from of n plus 1 to n plus 2. Oh, hold on, did I do it? Yeah. So n plus 1, n plus 2, and on, right? So that remainder is going to be less than the function f of x, right? The integral, the area under the curve, okay? And then also for this one here, since all the rectangles are above, then we've got the top where the remainder is going to be greater than, right? So the remainder is going to be greater than the integral. Okay, again, we're just starting at some value, and we're just counting the area of the rectangles from some value n on. Okay, and so again, this is area n plus 1, n plus 2, n plus 3, and so on. Same like here. So if we add up the areas of the rectangles, we get something that's going to be bigger than the area under the curve. Okay, so it's from the illustration of the rectangles, it's easy to see that in this case, the remainder is going to be greater than the area, right? Greater than the integral. And then for this case here, the area or the remainder is going to be less than the area from n to infinity. Okay, so notice a slight difference in the limits of integration. Okay. Now, so from this, it's easy to see that the remainder is going to fall between them, right? Now, the last piece of this is that we know that the infinite series a sub n is equal to the partial sum of n plus the remainder, right? We put these two together, we get the complete series. And so if we add, right, so if we look at this, we just add s of n to all three pieces, what do we get? Well, if we add s of n to the remainder, we get the series. N equals 1 to infinity of a sub n. And then here we just add s of n here. We add s sub n here, and we get the result. Okay? And that's it. Have a great day.